Our next speaker will be Sam Sternberg. Mr. Sternberg is a senior engineer with Dan Brown and Associates and has over 16 years of geotechnical engineering experience. He received a BS degree in civil engineering from the University of Kentucky. I guess an M division degree. I'm not sure what that is. No. Is that military?
No.
A master's degree, okay, with the New Orleans Baptist Theological Seminary, and an MS degree, minister's degree, okay, got it, and an MS degree in civil engineering from the University of South Alabama. He is a registered engineer in 8 states and serves as the ASCE Deep Foundations Technical Committee, DFI Testing and Evaluation Committee, the DFI Driven Piles Committee. He has worked as an engineer and consulting on numerous private and public projects, with primary focus on DOT transportation projects around the southeastern U.S. In relation to the topic, Mr. Sternberg is currently serving as the Alabama DOT's representative for the geotechnical work on the Mobile River Bridge project. Mr. Sternberg currently resides in Daphne, Alabama, with his wife and 3 children. Let's welcome Sam.
Awesome. Thank you very much. Thank you all for the opportunity to present a project that has been a part of my life for the last 5 years, and if it continues on this pace, probably for the rest of my career. Just kidding. Also, if you've seen this presentation at other times, I want to apologize in advance. You get to suffer along with me through this. Further, I've got to get this little legalese out of the way, little disclaimer. I know there's several of the team members from the concessionaire teams that are here and that are vying for the project. As a representative of ALDOT, the owner team, I cannot discuss specifics of the procurement process or entertain questions specific to the project. So thankfully that cut out half your questions. All right, so let's get rolling on this thing. So today we're going to look at a project overview. I'm going to give you a quick condensed view of what is going on with this project. Some of y'all may have heard of this, but it's just going to give you a little bit more information about it. Then this is number 2 is where I really want to camp out. A theme of this conference so far has really been about design testing, load testing during the design phase. And one of the things I want to help you guys do is educate yourselves on how you can educate your clients to do this type of testing and how it can really be beneficial. The third part is I'm going to talk a little bit about what we did on the load test program, quickly go through the results, and then just kind of give you a standing of where it's at. So real quick, the ALDOT advisory team, made up of Thompson as the lead, HGR, Mark McDonald, Dan Brown Associates, and a host of others. In December of 2017, 3 teams were shortlisted out of 4, and those include these 3 teams: I-10 Mobility Partners, Mobile River Bridge Group, and Gulf Coast Connectors. So now we've got all that good little stuff out of the way. Project overview. Mobile River Bridge project. It's going to be a new signature bridge over the Mobile River. It's also going to include 7 miles of I-10 Bayway replacement that's going to actually raise that level. And currently it's going to take it to a new 6-lane bridge in Mobile River. The existing Bayway is going to go to an 8-lane structure. It's also going to involve reconstructing 7 of the interchanges along that project. And the way this project began, it was a design bid build back in 2015. And then ALDOT said, hey, this is a lot more costly than we originally anticipated. So they actually switched midstream to a P3, a public-private partnership. Not only did ALDOT do that, ALDOT had to pass special legislation in the state of Alabama to even do design-build projects, because up to that point, they had not done design-build. So they passed a law that said if it's over a $100 million project, they're good to go with design-build. You know, a lot of states may, dip their toes in it. ALDOT decided to put in an express lane and bump it on up. So the concessionaire agreement will be for 55 years. Includes the operation of all that, and the ALDOT, now the estimate of that project is close to $2 billion. So it is a major, major investment. Proposed alignment, as I discussed with you, 7 miles of Bayway. The main structure is right there at the river. Let's see if I can get a pointer. So right here is where the main bridge is going to be, and then you have the 7 miles that's going to be replaced across. 7 interchanges. You've got 3 different cities to deal with. You've got the city of Mobile, Spanish Fort, and the city of Daphne. So you've got 3 of those. You've got 2 counties, Mobile and Baldwin County, and a partridge in a pear tree. So there is a lot of stakeholders in this thing. So you can imagine the environmental hoops. Real quick, just a quick, brief discussion Near the main piers, you're encountering, which is the MB1 boring, sand that's really a kind of a loose sand. You get into a little clay layer, then you go back into denser sand, medium dense to dense sands, and then back into a pretty stiff, very stiff to hard clay. On the Bayway, however, we had about 35 to 40 foot of weight of hammer type material. Muck, basically, is how we call it down in Alabama. And by the way, if you can't understand me, I've been in Alabama for 18 years, so bear with me. Then we get into more of a medium dense to dense sand and then back into a clay. So it was fairly consistent across the Bayway, that material, as you would expect in alluvial soils down there. So number two, this is where the meat of what we want to talk about, the decision for a pre-bid load testing. And, a lot of times when you go into these projects, you get limited information. You may get borings that are spaced really far apart, along a project alignment. You're told, hey, you need to come up with a bid. You need to do something with this. Well, on this project, ALDOT actually invested a lot of money in the upfront geotechnical exploration. In fact, they did over 24,000 feet of drilling with borings up to 320 feet. There was information for consolidation, shear strength, cone penetrometer testing. In addition to that, when the winning concessionaire team, they're going to have to do their own geotechnical exploration. So you're going to have a lot of information. So that should be enough, right? Depends on which side you're on. If you're an owner, you're like, hey, I've spent a lot of money. I've given you all the information. If you're on the contractor side, you're like, please, give me some more information. I want some more. So that's where we kind of got into this. And so from ALDOT's perspective, we needed to answer 3 questions for them that really help them understand why do we need to do a pre-bid load testing on this. So the first one we wanted to address, well, what are the project risks with the foundations on this project? Obviously, most of it is going to be across the Bayway. You're going to have a lot of foundations in there. What are those type of risks? How much will it cost? We wanted to flip this one because that's really what every owner wants to know. How much is this going to cost me? Well, really, let's look at how much this is going to save you in the long run. And then why is this important to the project? So the first one, this is a critical path item in the schedule. Bayway has so many piles on it, that's going to be your critical path forward on this project. And a lot of the contractors, anticipate that. So what can we do to help them out? The high foundation loads, you're going to have a lot of those with the storm events, the vessel impacts, and the performance issues. You do have all this soil information, but it's really good to actually marry up those soil parameters with a good load test. And so that's one of the things we wanted to try to help the teams out, understanding the dynamics of matching up and calibrating maybe some of that geotechnical information to a load test. So it helps them with their design be a little bit more efficient. And drivability, we wanted to look at the means and methods. What do they really need to use? If they got a jet, that takes extra time. If they can just drive it from the get-go, save some time. So how much will it cost? Well, this was an interesting one. We had to really put our pencils to work on this. But we tried to give them 2 different ways to look at this for how much money they would invest. One of them at the time when we came up with this in 2017, the estimated project cost was about $1.5 billion. So what we said was, okay, let's be conservative and say this project, about 40% of the project cost was going to be in the foundations, trying to be conservative. So if you did that, that's about $600 million. So what if you saved 1% of that $600 million with, some load testing? That's a $6 million, you may have to play with for a load test. You can do a lot for $6 million in a load test. The other way we wanted to look at this was, okay, the Bayway is about 7 miles long. In 2 directions, that's 14 miles. And the existing span lengths are about 65 feet. So we assumed 3 foundations per bent. And say through this, they were able to, through calibrating their soil parameters and their design, they might be able to shorten those piles up, say 10 feet per pile. Now you're looking at over 34,000 feet of pile. That is a lot of pile that could be potentially saved in their schedule and their contingency, because they're supposed to have this thing constructed in about 5 years. And that's a lot. So then we finally got to the point, why is it important to this specific project? And obviously some of the same things kind of wrap back around, but it's information on the performance of various foundations. We're kind of taking some of the guesswork out for them. We did in this test, as you'll see, different types of foundations. We did drill shafts, we did pipe piles, we did concrete pipe piles, steel pipe piles, and pre-stressed piles. So we gave them a variety of some of the different sizes. Mitigation of the risks and unknowns. How does the installation of these foundations go in? How does that help them out? What can they do? And then obviously continue to provide that unit side and base resistance, and then improves the reliability, therefore reducing risk. If a lot of these are doing some of the same things, they're fairly consistent, that helps them understand that a little bit more. We also did restrikes, so we were able to help them out with a little bit of looking at some of the setup factors down there. In Alabama, we have some soft clays, but majority down where this project is, there's a lot of sand. So the dissipation of the pore pressures work fairly well. Setups are moderate, and you'll see a little bit of that when we go through the results. It also assists in the establishing specifications for the pile installation form. This is the big one. Concessionaire teams and the design build teams always put in a contingency, and especially when it comes to the geotech, because that's a big risk item. For a concessionaire, especially in P3, a concessionaire, this is a financial deal for them. That's it. Beginning, close, financial deal. At some point in between there, a bridge gets built. If it does not make sense as a financial deal, that's going to be a problem for the owner, because the owner's going to have to cough up more money. So if they're having to raise their contingency on the concessionaire team, and now the owner's having to kick in more money on this side. So if they can try to reduce this contingency on this side on the team, then they have to come up with less money if they can make that work. Make sense? If it doesn't, we can talk later. And then also the foundation installation schedule to help teams better understand, like I was talking earlier, can they drive these really quickly, effectively, and keep moving. The other part was all this information was equally provided to the teams. All three teams got this information. They got the installation records, the concrete pour records. They had the opportunity to have a representative on site to watch all of this, fully provided to them. Load test program. So ALDOT looked at this and they said, go. You know, these are the 6 phases of a project as soon as this hits, because of how fast this was. We didn't really get through all of these. Number 3, panic. I kind of induced panic on the environmental people just for a second. I'll tell you this funny story, because I enjoy doing that to them. I walked in once ALDOT said go, and I said, hey guys, to the environmental people, I said, I need to get a permit for the Bayway for doing some pile testing. And they said, well, what are you going to do? I said, well, I'm going to set off an explosion. Don, I know it's a slow burn. It just happens to be really quick. But, and so after they picked up their jaws off the floor, they said, no, really, what are you going to do? I said, no, I'm really going to set off an explosion on the Bayway. And so then I showed them a video. Again, they had to pick up their jaws off the floor. And they said, okay, so are you going to remove these piles after you're done? I said, no. And they said, well, can you cut them? I said, I can do that for you. So it's always fun to mess with the environmental people every once in a while. So load test schedule, we got the approval in August of 2017. They said, hey, for this to work originally, and for me to help you understand this, in May or June of 2018, that was when the final RFP was originally scheduled to come out. So we had to have all that information done in a short amount of time. So they gave us about a month to put plans together, another month to get through Office of Engineer and advertised. And that ALDOT did wonderful. They worked alongside of us. We were shifting paper and designs back and forth. And it was let officially in December, and the notice to proceed hit in January. The other foresight that ALDOT had in this, they allowed the teams, the proposing teams, to bid on the pre-bid load testing. So that really worked well because, one, they had a vested interest, so they were hoping that might assist in the cost of this project. The second was they were hoping they had enough participation. So that was, you know, the other part of that. And so sure enough, they got 2 bids, and the 2 bids were two of the teams. Good. Okay. So 2 of the teams, one was 3.4. Jordan Pile Driving had a laydown yard right there, so it worked out well for them. Real quick, I've got about 5 minutes. Load test program. We did a drilled shaft, 72-inch in diameters with a 78-inch permanent steel casing. That was installed to about 54 feet below the existing ground surface. The actual length of that shaft was about 175. We did lateral rapid load testing and bidirectional load cell testing. We did driven piles, H piles 14 by 89, and the precast concrete piles. Along the Bayway, we looked at 54-inch concrete cylinder piles for the majority of the way. Sorry, I hit the wrong button. And a 30-inch square pre-stressed concrete pile as well. Also, we did the restrikes to get a little bit of setup. Finally, we ended with a 60-inch steel pipe pile near the base of the main pier. So we had a drilled shaft and a steel pipe pile just to make sure we went well on that one. We originally told them they could vibrate in the first 100-foot section, add a 75-foot section, and then drive it. The contractor elected to do the 75-foot section first. We didn't have a problem with that, so we rolled with that one. So in the lower left-hand corner, that's where they had the 14 by 89s and the 18-inch precast piles. Here's one of the main piers. The other main pier will be over here in the water. And then along the Bayway, this is where we did one 54-inch. We did 2 54 inches right here and a 30-inch. And then over here we had 2 54s. This one was where we wanted to really evaluate the installation techniques, and this is a big lesson learned for us. When I was reviewing the results that came out of this, the capacities were almost identical, and I called up the C&I guy and was like, hey, what happened with this? They're supposed to jet to a certain depth with the pile and then drive it the rest of the way, and the other one was just an optional jet. And he said, well, when he went back to look into it, the contractor had jetted the day before down to the specified tip, then stuck the pile, rather than sticking the pile and then jetting the pile down to that tip and then driving from the rest of the way. So when you look back at the specification ALDOT had, the contractor did by the letter of the law. Did he do the intent? Not necessarily. So that was a big lesson learned. Always make sure to double check those specs. And also in the theme that everybody's been using a D180, we also had a D180 on site as well. So it was a big old hammer. I actually cracked the crane mats when they lifted it off and water came out of the ground. So I had a fun conversation with the guy on that one. So real quick, I'm not going to show this video. A lot of people have seen a rapid load test. The funny part about this one was we did a rolling traffic block on I-10. So traffic was not allowed. And it gets eerie when you're standing out there and traffic's been, hitting the every segment and you're hearing that, and all of a sudden it gets quiet. Then you shoot that thing off and it echoes through the whole valley. So the first time we're almost back to the dock, a C&I guy gets a call and he said, hey, did you notify everybody that you need to notify, like the fire department? He goes, well, I told the police. Thought that covered everything. He said, well, the fire department's out here, and sure enough, all the fire trucks were running out there because with the rolling traffic block, you had somebody call in when they saw the flame shoot out the top and thought it was a terrorist act. And so that was fun. Results, this will be posted on the website. I know I'm running out of time, so we'll go through this. But obviously, we did the restrikes. I have this summarized. We had the rapid load testing results. Here's what we saw for the setup factors. Typically, we ran those anywhere from about 1.3 to 1.8, depending upon the pile and depending upon where it was loaded. We did have an anomaly, a little one that was a little bit less down here, but those were also, it was a shallower tip depth. On the drilled shaft, with the 175 feet length and the loading, in the upper soils, we got about, a half to 0.7 KSF in the skin friction. Then went to 2.5 in the denser sand. Back in the clay, it was back to about 1.5, and then back to 2 to 3. The end bearing that we mobilized, though, ALDOT doesn't do a lot of drill shafts down there, but I think it really showed them. End bearing, they were able to mobilize 170 KSF. So it worked really well. It was drilled under polymer as well. This one I will show, maybe. Maybe not. Oh, there it goes. So this is the final lateral load test we did on this with a 6-inch deflection, max deflection. And everybody kind of really enjoyed it, and it kept sliding back and back, and we were hoping it wasn't going to go into the Boga River. Worked well. And ignore that big mound of dirt behind there because that's archaeological. So we'll ignore that one. Drill shaft summary. So matching that up, we did 4 load cycles on the lateral, as you can see there. Matched up really well with the PY curves on the linear, non-linear springs. And going forward, right now we are at the point where they're having the public meeting next week. Supplemental EIS has been signed. Once the rod hits, they'll drop the final RFP, and proposals are due at the end of this year. So as I said, probably the next 5, 6 years of my life maybe still wrapped up into this. All the information is provided to the teams. Will we truly know the savings? Probably not. Each team will use those differently, but we know we're saving enough money that should help facilitate the project forward. So with that, I believe I'm out of time. Real quick thank you to ALDOT, Jordan Pile Driving, AFT that worked with Jordan Pile Driving on load tests. Any questions?
Yeah, great. All right, thanks. Thank you, Sam. Yeah, we're out of time for questions, so